Hello. Have you ever wondered how electricity works? After all, it's in everything around us. It's in our computer, in our bodies, and even our Mickey Mouse shaped landline phone. Well, I'll explain to you how it works, plus a lot of related concepts, such as current and power, in just around 5 minutes, hopefully. First of all, you must understand what an electron is. An electron is a subatomic particle, which means it's a part of an atom. So what's special about them? After all, there doesn't seem to be anything particular about them. No pun intended. Well, the thing is, these little guys can move, and when they do, electricity happens. You may be wondering, alright, but why do they move? Here's how. Electrons, by nature, have a negative charge. What does that mean? It means that they will be repelled by negative fields and thus be attracted by the positive fields. In this case, the positive and negative fields are created by a voltage source, which can be something as small as a battery to something as big as queso, a power plant. Voltage is by definition, and I quote Wikipedia, the difference in electrical potential between 2 points. Think of this as the pressure in a hose. The pressure, which in this scenario is the voltage, will cause the electrons to go through the circuit when there is a difference in the electrical potential between 2 points. This difference will create an electric field going from the positive to the negative terminal, so the electrons, as mentioned earlier, will be repelled by the negative field, causing them to travel all the way to the positive field. The higher the voltage, the greater the difference in electric potential between 2 points, therefore a stronger electric field, which will cause the electrons to move quicker and with more force. It is worth noting the fact that in electrical drawings and diagrams such as this one, the electrons are considered to come out of the positive field, also called terminal. So now you might be wondering, so why did you show me all of these electrons exiting from the negative terminal? Well, it's because of this guy. You probably have never heard of him. Back when Benjamin Franklin was doing his studies on electricity, he defined the current direction as the flow from the positive charges to the negative charges, which he got wrong. But we just go with this statement to not complicate ourselves. Another important concept to know is electric current, and luckily it's a lot simpler than the definition of voltage. Electric current is the flow of electrons through a conductive material, and which is measured in amperes. In simple terms, it's the amount of electric charge flowing through a material. This is important because the higher the current, the higher the power is. Alright, yeah, I'll explain to you what power is. Just give me a break. Alright, let's go. Power is no more than the amount of electricity a device or a circuit consumes in a second. This is useful to know when you are looking for new appliances, because the power of the device is represented by the watt. Before I finish this explanation and video, I must tell you one last concept. Resistance. Yeah, not that resistance. This resistance. Resistance is the position a material presents to the electric current. Almost every material has resistance, even you. The higher the resistance of an object, the less current will flow through it for a given voltage. And that is electricity and its related concepts, explained as quickly as possible. There are of course some other important details and relationships that I left out for the sake of simplicity and not bring back bad memories honestly. However, this is electricity in a nutshell. Thank you for watching.